Hi guys, this is Manoj here. I'm having around 15 years of industry experience. Okay, so let me walk you through a few of the concepts of DevOps. I'm working in a file today. Okay, let's say file name is a.txt. Okay, I have written some contents here. Let's say 1, 2, 3. Not I have made a change in the file and I have got the contents 2, 3, 4. Okay, for example, the first day when I started working on the file, the date was 7th of Feb. Then I made the sub changes in the file. Okay, and the date was 8th of Feb. Then I made a change in the file. Okay, that is 9th of Feb. Okay, suppose now if I want to fetch contents of 8th of Feb, do you think I can fetch the content of 8th of Feb or 7th of Feb? Okay, two times I have overridden the file. Can I extract the content of 7th and Feb? The files are getting overridden, right? So guys, since the changes has been overridden, okay, as of now I'm talking just for 2 3 days. Suppose that okay, I have 10 15 days are there which I'm working on the same file. After 10 days I realize that what I have done 10 days back was very important for me. So I don't have option to extract it, right? I don't have option to extract it. So what is the option left out for me guys in this case? How I can get the content of 6th of Feb or 7th of Feb? How I can get the contents of any previous date? So there is no point guys, I can make it simpler other than version control system. So if I will bring a system, okay, wherein I'll able to keep track of their versions. Okay, let's say if I'll take a system, let's say any system, okay, wherein you know if I will make a version of that, okay, or track a change over there or make a reference over there, okay, let's say this guy, when I made a change I called it as a version control system v.1. Okay, and then next time if I save this change as v2.0, okay, and next if next change if I can track a v3.0. So just think about if I have any such system is there, okay, then easily I can extract, let's say a.txt 7th feb what was the content of the file. I can easily track with the reference v1.0, okay, or 2.0, okay, or 3.0. Okay, so this system by which we can keep track the changes of whatever file contents were, I'll be calling it as a version control system. So guys, version control system is a very generic term. Okay, what is a version control system? With the version control system you will keep track, you will able to keep track of the files, nothing else. Okay, and that's why version control systems are very important, because like for last 20 25 years people started extensively working on the file systems. Okay, and when you're working on the file systems it's actually mandate to maintain their tracks, okay, like what was changed when, so that you can work accordingly. Okay, so that's the reason version control systems came in picture in the market. So guys, there are many version control systems are there in the market. I'll tell you what was the journey. So guys, the most important version control system which came in market, which made a huge kind of hit, was CVS in the market. Okay, CVS in the market. CVS was used long back, like in early 2000, people were relying on the CVS. But CVS has the biggest problem that it doesn't have any pattern or any ways of branching. So people move to another version control system. Then people move to SVN as another version control system. Okay, but SVN also had a drawbacks, like SVN was more of a folder based, and that time it was not security wise very strong. okay, and not very stable product that point of time. So people started moving to TFS, okay. So people started moving to TFS. Now TFS was very good version control system, almost 5 to 7 years. TFS was like very hit product in the market, but suddenly people started thinking about TFS cost. So TFS cost was very high. Okay, TFS is a Microsoft product, very high or heavyweight product. Okay, because of that, people started looking options of TFS. Apart from that, guys, there is one more version control system is there, which I never use, but in industry it exists. Perforce. So these are some version control systems are there, but after TFS, people started realizing about the cost. TFS had a great cost, but TFS had a features also, and people started thinking about different type of version control systems also. So in market, almost like 5 7 years back, okay, 2 3 version control systems have came in market, and Mercurial was a version control system which came in market, which actually started changing thought process of everyone. Okay, people started thinking in a different version control systems. Full form of TFS is Team Foundation Server. So Bitbucket, GitHub, GitLab, they are the later version of version control system. Okay, but people started thinking about Git and Mercurial. Like, what is the special in the Git and the Mercurial? Okay, so let's talk about how many type of version control systems are available in the market. So first talk about centralized version control system in the market. CVCS. CVCS is the version control system in the market. Okay, centralized version control system. So what happens is, let's say you have a centralized VCS is there, like for example CVS is there, or SVN is there, or TFS is there. Okay, so let's say this is your local copy is there. Okay, your laptop is there. So first what you will be doing is, you will be checking out the code, and then you will check in back your code. You will check out the code, and you're checking back the code. So the very simple ways of working is, you have a local copy is there. In your local copy, you'll be check out the code, and once you make the changes in the local copy, you will check in back the code to the centralized version control system. Now, because guys, because of any reason, this guy is not available. Okay, let's say this guy is sitting in your company premises and you're working on the weekends, and because of any reason your VPN is not accessible, and this guy is not available. Okay, this guy is not available, or maybe at your place internet is not working, or suppose you are traveling, like India, train journeys are like little high. 30 40 hours journeys are very common between South India to the North India. So suppose this guy is not available guy, then what is the option left out for you guys? Can you develop your code when this guy is not available? So guys, centralized version control system was the biggest bottleneck maybe 5 7 years back. Okay, and I didn't explain you the concept of agile. In agile world, we have to work in very fast pace. We can't afford to lose even one day, because your timelines are very strict. Okay, so when your timelines are very strict, you have to work in a very fast way. So that time it's not possible for you to wait to afford any kind of network glitches or any kind of other problems. Okay, so it's not possible for us to check in and check out the code when this guy is not available. So what people started thinking is, let me come up with the different ways of working. Okay, let me come with the concept of distributed version control system. Okay, DVCS, people started thinking about DVCS, distributed version control system, or distributed VCM. So what distributed version control system says is that treat your local copy, treat your local copy as a local repository. So let's say I have 4 developers are there. So they are working in their local copies. So in their local copies only, they can keep track of their changes like a version control system. So their local copy will be treated as a local repository. Okay, let's say this is a developer 1 copy is there, this is a developer 2 copy is there, this is a developer 1 copy, this is a developer 2 copy, okay, this is a developer 3 copy. So they are treating their local copies as a local repository. Okay, they can exchange the code within themselves also. There are ways are there, but most likely when they will complete their local development, then it's a time to their to move their code to the remote repository. Okay, so once they are ready, they can move their code to the remote repository. Remote repository. Okay, until they are not confident, or maybe they are in the offline network, or they are not in the VPN, they can work in their local network. It's fine in local repository. Afterwards, they are comfortable, they can move their code to the remote repository. So here local repository, when I talking about, it is a Git. Okay, it is a Git. Okay, when I'm talking about a remote repository, guys, it could be anything. Multiple remote repositories are there, like it could be Git, it could be Bitbucket, okay, it could be GitLab, it could be Azure repo, okay, and it could be AWS repo also. So a lot of repos are there which can be treated as a remote repository. Okay, I personally worked on GitHub, Bitbucket, Azure repo, and GitLab. AWS repo I never worked on, but these repositories will be treated as a remote repositories. Okay, these repositories will be treated as a remote repository. Local repository can be Git or Mercurial. I never seen people working on Mercurial. Most of the people works on Git. So Git GitHub is a combination of the repositories. This is the interview question also, and this is a very important concept also. What is the difference between centralized version control system and a distributed version control system? So difference between DVCS and CVCS is, CVCS, you are not working in the distributed way. You have to be rely on single point of failure. But when you are in the DVCS world, you are actually working on multiple local copies. Once you are confident, you can move your code to the remote repository. And remote repository flavors could be multiple: GitHub, Bitbucket, Azure repo, GitLab, AWS repo. Local could be Git and Mercurial. Okay. And our topic today is Git and GitHub. So we'll be touching about a local repository and a remote repository, that will be Git GitHub. So let's talk about Git, guys. So there is something called two-tree architecture, and there is something called three-tree architecture. Okay, so true tree architecture is being used by traditional version control system. Okay, what is a true tree architecture? You will develop your code into the local copy. Okay, and then you will check in your code to the your remote copy or your centralized version control system. Okay, so this is two tree architecture. We call it as a two tree architecture. Okay, but wherein in the three tree architecture, what happens is, in your local copy you will be developing your code. Okay, then you will be moving your code to an area called staging area. Okay, and then you will be moving your code to the local repo. Okay, this is three tree architecture. Like one tree is being added here extra, that is the staging one. Okay, and once you are confident about your code, you can move your code to the remote repo. Okay, so this architecture, which will be having one more layer embedded, we call it as a three tree architecture. This is three tree architecture. Okay, so why this staging is required? This is required because this gives you some flexibility when you work. Sometime in between of your work, you actually realize that you need not to work on the same file. You have got a different logic. So instead of discarding that files, you can move them in a different areas. So that's the reason staging is required. When we will do the deep dive of the staging in our regular course, we'll talk about more on the staging, but this is a kind of architecture which is given by Git company. Okay, so 3 tree architecture is nothing but given by distributed version control systems, which is like Git or Mercurial. Okay, will you be developing your code to the remote repository or local repository? Local, right? So local, so we will be focusing on local. Remote, actually, if you search on the Google also, internally it says GitHub or Bitbucket, anything. It actually internally uses Git only, but how it is being adjusted internally in the remote repository, that algorithm is unknown. You can check on the Google also, and no one bothers about also. There is some simple command is there by which you can push your code to the remote repo. It's not local copy, it's a local repo. I'm sorry, typo mistake. Okay, now guys, I will show you hands-on. I know this is little confusing, so what I'll be doing is I'll be going here somewhere and I'll be creating a folder called Git Practice, Git Bash here. Okay, and then what I'll be doing is, so Git Bash is, guys, this is just a client is there. Okay, which is required to connect with the local repository. Okay, so Git Bash, you can download it from internet. For Windows, Git Bash is being used. For Linux, Git client is being used. So Git Bash is just a client I have already downloaded, and I launched the Git Bash. Now first I have to initiate a repo, local repo. So this is being initiated. You can see this is being initiated. Okay, now what I'll be doing is I'll be adding a file in this repo. The file is, let's say, a.txt is a file which is being added. Okay, first I'll be adding my file in the staging area. To add a file in the staging area, I'll be typing the command git add dot. This is being added. Now I'll be typing the command git commit -m and added in local repo. Now I will be adding my file into the local repo. So now the file is being added to the local repo. So if I compare this with my architecture, I had a local copy wherein a.txt I have created. Then I moved my file into the staging area, then moved my file into the local repo. Okay, let me add one more file. That's b.txt. Same I've added in the local repo, local copy, git add dot, git commit -m, added in local repo. This is being added. Okay. Now guys, if you want to see how many files are being added, so what you can do is you can type a command git log. It will tell you how many files are being added. 2 files are being added, and every file will be added with the reference ID. So this reference is nothing, we call it as a commit ID, or we call in the technical world as a SHA code, SHA code. This is nothing but a hexadecimal representation of what is being added in the repository. Okay, who has added? Manoj has added, and this is the message which I passed in -m command, added in the local repo. Can I move a code directly to the commit area without moving it into the staging area? Is it possible? It's possible, guys. How it's possible is, okay, if you have an existing file is there, okay, as of now we have a.txt, b.txt is there. If I'll do a git status, you'll see no changes there. If I will go and make a change in this file, okay, let's say if I'll make this file, this is my master file. Okay, and if I will do git status, you will see this file has a change. So this file is eligible to go to my staging area. But if I will commit it directly, git commit hyphen m, sorry, hyphen a hyphen m. So this is another keyword is there called hyphen a. Okay, which will allow me to add directly a file into the commit area if that is a existing file. Okay, if I'll add a file directly, added file in commit area, it will allow me. See, this will allow me. If I'll do git status now, okay, it says nothing to commit. So always remember guys, when you're working, okay, on a file which is an existing file, a change will be allowed to directly commit it, but when you're working in a new file, for example, if I'll add a file, c.txt file, if I'll do git commit -a -m, I would say directly adding c.txt, it will not allow me. It say this is an untracked file. Okay, so this is an interview question also guys. If someone is preparing, can we add directly a file into our staging area, I mean commit area, instead of putting them in the staging area? -m is a keyword which will allow you to add a message in the commit area. Okay, now guys, let's talk a little more. Okay, so which branch we are working on at the moment? We are working on the master branch, right? So guys, if I want to see how many branches I have, you can type the command git branch. If you want to create a new branch from a master, you can type git branch, feature branch, any name. I'm just giving a name, feature branch. Now if I'll type a command which branch, you will see that it's a listing both the branches, master branch and the feature branch. If I want to move to a feature branch, the command is git checkout feature branch. Okay, so I've switched to the feature branch now. You can see here I have switched to the feature branch. Okay, now guys, if let's say I'm into the feature branch and if I want to switch back to the master branch, so easily I can switch back to the master branch, git checkout master. So I have switched to the master branch. You can see here I was on a feature branch. Now I've switched back to the master branch. So let me create one more file, e.txt, git add dot git commit -m, added some files in master. Okay, so C and E's are being added. How many files are there in the master? 4 files. And how many files should be there in my feature? 2 files. Because I added these 2 other file in the master after I created feature branch. Okay, so in a repository I have 4 files. Okay, so branches are just references. When feature branch was created, the 2 files were not added in my repository. Okay, for example, in the backend folder wherein I was working, at the moment 2 files are there. But if I will move my pointer to the master branch, git checkout, you will see that in my backend folder it will show me 4 files. See, 4 files. Okay, so in my repository I have 4 files. It's just a reference, you know, where it is pointing to. So guys, now I have 2 branches are there, git master, sorry, git branch. If I'll do, I have feature branch is there, I have master branch is there. Okay, git branch, feature branch and the master branch. Okay, okay, now what I'll do is guys, I want to connect them to the remote repository. So what I can do is, let me go to my master branch. I will go to my remote repository GitHub. This is my remote repository. I will create a new project. Project is nothing but the repo, 9th of Feb. This repository I made it public. I created this repository. Okay, and then what I'll do is, there are some steps are there. Okay, how to connect my remote repository to the local repository. So I will come here. Okay, git remote add origin, this one. Okay, so in this origin keyword, my remote repository URL has been added. Now the next step is git push hyphen new master. So as of now, I'm pushing my master branch to the remote repository. So git push hyphen new origin master. Origin is the keyword wherein this remote repo URL is being added. Okay. So when I'll type this, it'll ask for my credentials for sure, my remote repository credentials. Why it's not asking? Yeah. Oh, it is public. Okay. So why it's not asking is because maybe in the previous class I would have passed my repository credential already. Okay. Now we will go to my remote repository and we will see whether the data is being added. Yes, master branch data is being added, but we will not see the feature branch here. Okay. So what I will be doing is I will be pushing this time data of my feature branch. So instead of master, I'll be pushing feature branch data. Okay. It is pushing my feature branch data also. In my feature branch, I had two files were there. So you can see here in my feature branch, I have two files are there. In my master branch, I have four files are there. And this is how we can connect to the remote repository. Now guys, if you want to bring some files from remote to the local, what you can do is you can create a new file to the remote repository. I'll add some file, test file. So 9.5 file I've created. Now we'll go and add some content. This is my test file. Okay, sorry, I'm back now. This is my test file. Okay, I'll come here. I will commit it. So directly I'm committing a file over here. Okay, so a new file, test file is being added here. Okay, now that file is not there in our local. In our local, if I'll go to ls, this test file is not there. So what I'll do is I'll do a git pull. It will pull the file from remote to the local. You can see this test file has come from remote to the local. If I'll do ls, you will see test file is being added. When I have to take an entire repository, I do a git clone. As of now, one file is being added in the remote repo, so I did a git pull. That's it, nothing else. So we have talked about a version control system. Like to track the periodic changes, you have to have a place wherein all these changes can be tracked, and that system is version control system. Like different versions you are maintaining through a version control system instead of taking a backup and all. Okay, so as I told, multiple version control tools are there. Git and Mercurial, these are distributed version control system, wherein SVN and CVS, they are centralized version control system. Okay, and over a period of time you can see the popularity of the Git is like kind of the high demand nowadays, wherein SVN, Mercurial, CVS is in less demand at the moment. CVS is kind of a dying product. Mercurial has picked up, not great, but SVN is still there in the market. So you can see in GitHub, you have to connect to the local repo, local copy, it goes to the local repository, then it goes to the remote repository. This is called distributed version control system. So Git, we have seen like, we have multiple people are there, they can work together in a distributed fashion. And once they are ready, they can move their code to the remote repository. And this is very important slide, guys. These are the important features of the Git. The first feature is distributed. So when I'm talking about distributed, each local copy will be treated as a local repository. So your repository is being distributed among multiple machines. It's compatible. It's compatible for Linux and Windows. It's non-linear. Hence, you can move your code from one repo to another repo. Reliable. Most of the open source projects are on this repo. Secure also, since open source projects are there. Economical. Git is a version control system. All are there. Okay, so we have talked about the concept of the central repo and the local repo just now. Okay, so Git is a local repo and GitHub is a remote repo. Okay, GitHub will be connected to the local repo. Central repo based on the remote server .git folder, means of team share exchange. Local repo located in the local machines. Okay, for a particular person. So we have talked about these commands, git init, git add origin, push, pull, branch, merge, rebase, status, add, commit. So what is the rebase, guys, and merge? Instead of explaining you in theoretical way, let me explain these two commands. with a hands-on. So guys, let's merge two commands. Okay, how we will merge these two commands are, let me create a branch, feature branch one. Okay, let me move to, okay, first of all, let me see now how many branches I have. Feature branch I have, this branch, let me delete, let branch -d and branch name. This is being deleted. Now if I'll do a git branch, I have two branches are there. I'm in master branch. Let me do a checkout to fb1 branch. Now let me add some files. Touch one.txt, git add dot git commit -m added one.txt. Okay, git, sorry, touch 2.txt, git add dot git commit -m added 2.txt. Okay, so guys, I'm in fb1. I have added two files. Now let me go to my master branch, git checkout. Okay, and guys, here I don't have one.txt file and two.txt file. So what I'll doing is I will do git branch, sorry, git merge and branch name, which is fb1. Okay, so what I'll be doing is I'll be merging one branch to another branch. So you can see this one.txt and two.txt, both files are being merged to my master branch. Okay, so if I'll do git status, nothing to there to update. This is a master. If I'll do ls, you'll see test file, sorry, one.txt and two.txt, both are being added. If I'll do git log, you can see these two files are being added. Okay, now guys, the merge is just a way there to merge your commits. But guys, if you see one.txt and two.txt is there. Now what I'll do is I have branches are there, fb1 and master. Let me delete this branch, git branch -d fb1. This is being deleted. Now what I'll do is guys, I have these files are there with one branch is there, git branch master is there. Okay, if I'll do a history, git log --pretty equals to one line, you will see little complicated history, zigzag history. Okay, so while merging one branch to another branch, if you want to make your history more simplified, okay, so we have another type of merge technique is there called rebasing. Okay, rebasing. So what I'll be doing is let me create one more branch, fb1. Let me check out to this branch, fb1, and let me add some files here, touch one.txt, numeric one.txt, git add dot git commit -m added one.txt. Okay, now we'll add one more file. Okay, now what I'll do is I will go back to my master branch, and this time what I'll be doing is instead of merging, I will use the command rebase fb1. So you will see fast forwarding to the fb1. This time it will merge in my master branch, but it will be a linear merge. Okay, if I'll do git log -pretty or one line, you will see one.txt and two.txt. It is little linear in nature. Okay, it is little linear in nature now. Okay, so this is kind of advanced concept of rebasing, but rebasing and merge, both are type of merge techniques are there. Okay, so we have talked about git init, git clone, we talked about git push, pull, everything these commands we have talked about. Git rebasing also we have talked about. Okay, so this is very important diagram guys when you're working with the remote repo and the local repo. So you are adding a file, you are committing a file, you are pushing a file, you are pulling a file. For a branch change, you are doing git checkout, and for merging one branch to another, you are doing git merge. So guys, if you remember this diagram, it's very easy to understand the git flow. So this diagram should be by heart remember by you. Difference between pull and clone. So guys, clone will clone your entire repository. Pull will be used to get incremental updates. Okay, let's say if you want to clone your entire repository, you do a git clone and the repository URL. If you want to just pull few of the files, okay, which are incremental, which are newly be added, so pull will be on top of a clone. After you cloned it, then you pull it. Okay, clone will be a fresh update for entire repository. Okay, so guys, my motive was to make you comfortable on this slide. Okay, and we have discussed all of the commands, like how to add a file, commit a file, pull, push, check out, merge. If you understood the flow, then you're good for the basics of the Git. Okay guys, bye for now. Thanks for your time and have a great day.